Welcome. In this video we are going to learn how to do qualitative tests for G6PD, and this particular test kit or reagent was developed by Reckon Diagnostics, and it's a very good G6PD qualitative test. They specially call this the G6PDH Hemopak, so that is the name that they have given it. And in this video we'll go through how this is done. So this is how the box looks like all around, so like this, and then so we're going to open it. So if you open it, you are to expect an insert which will give you the directions as to how the test is performed. So we'll go through the insert as I show you the various reagents. Okay, so this is how the insert looks like, very similar to any insert that we have. So it gives you the product highlights, it gives you the principle, and then what you're to expect in the package, and then some precautions. Then it shows you how to do your working reagent, and then some storage conditions for the reagent, the sample collection or the sample type that you need. Then we'll look at the principle, then how to prepare the red cell hemolysis, which is here, then the observation that you're supposed to do, and finally how to read your results. So basically this is how the insert looks like. Okay, so so when you open the box, you have, or you are to expect 4 different types of reagents. So reagent 1 is here, as you can see. So this is G6PD1, that's reagent 1, and you can see it here. So G6PD1 is a coenzyme substrate, so you have 13 of that in the box, 13 of that. Good. So this is reagent 1, and then we have the G6PD reagent 2, which is a buffer, so you have 1 of that. Okay, then the reagent 3 is your lysine reagent. This is how it looks like. You're also supposed to have 1 of that. Then finally we have the inert oil, which is G6PD4. Okay, so these are basically the reagents that you need. Okay, to begin the test, you first need to prepare a hemolysis. So to prepare the hemolysis, you need the lysine reagent and then your blood sample. Okay, so the test is such that your HB level will determine the amount of blood that we are supposed to use for the test. But generally speaking, you can use, according to the instruction here, you can use 1 ml of the reagent to 20 microliters of the blood. And as I've already mentioned, the test is such that the higher your HB, the lesser the amount of blood that will be required. And so if you look at this table, if you have a lower HB, let's say 7 to 9.5, then we'll have to increase your the amount of blood that we are supposed to use. So here we'll use 40 microliters instead of our normal 20 microliters. So the table indicates that. And of course we are going to use an EDTA, anticoagulated blood. Okay, so I'll prepare my hemolysis with my blood sample. Okay, so I have some blood sample here that I want to use for this demonstration. So I'm going to pipette, this is my micro pipette. I'm going to pipette 1 ml. So I have 500, it's set to 500. So I'm going to do a double of this to get 1 ml of my hemolysis. Okay, so let's see whether we can do this. So this is a plain tube that I'm going to use to prepare my hemolysis. So I have it here, and then this is the reagent 3, the lysine reagent. I'm going to open it, and then we are going to do a double of this to make 1 ml. So 1, and then and then 2. So this makes 1 ml. Okay, so I'm going to then add 20 microliters of my blood sample to it. So this is my pipette for 20 microliters. I'm going to shake my blood and then I will add it. So this is 20 microliters. I'll add it to. Okay. Then I can cover and then mix it. So this is how it looks like. So you're supposed to keep this in the fridge for 10 to 15 minutes. So we'll do that. So where is that? So mix well and keep in the refrigerator. That's 2 to 4 degrees for 10 to 15 minutes. So we're going to keep this for 10 to 15 minutes, and then we'll continue the video later. Okay, so let's take it to the fridge. Okay, so I'm going to keep it here for 10 minutes, and then we'll continue. So it's after 15 minutes and we bring our hemolysis out. This is how it looks like. Okay, so from here, once you are done preparing your hemolysis, you can now prepare your working reagent. And to do that, you need the coenzyme substrate and then the reagent 2, which is the buffer. Okay, so this is how it looks like. You can peel this foil off, or you can stab it using a needle. Any of the two is fine, but in this demonstration I would peel it off. I have one that I've already peeled off, so I'll open it and then I'll transfer that is 0.5 mils of the buffer into it. So this is how it's. So I'm transferring that's 500 to it. So that is 500, and then from here you can mix. You get this blue color, as you can see. So you shake and allow it to mix well, and you're supposed to use this within 10 minutes of constitution. So you make sure that everything dissolves well before you proceed to the next stage. So next, you actually transfer the hemolysis into the working reagent. Okay. So I'm going to do the transfer now. Let's probably. Okay, so this is what you get. I hope you can see it very well. So it change. There's a slight change from the blue color that we saw initially. So when the test is complete, this is supposed to change to brown, or is to have a brownish color. So what we're going to do is that we're going to keep this in the what do you call it? We're going to incubate it at 37 degrees for 30 to 1 hour. So then from there we can read our results. If it has turned into brown, or it has turned brownish, then the person is what do you call it, normal. Okay, and that is so because if the person has the enzyme will act and then will actually turn this into a brown color. If the enzyme is not present, it means that it will, or it's not in sufficient quantity. It means that it will take a long time before it will be able to convert this the dye into the brown color. Okay, so that is what you have to expect. So those who are defective will actually have, or will take a very long time, let's say 2 to 24 hours before they will convert. So this is how we're actually supposed to read our results. So in normal subject, discoloration time is between 30 to 60 minutes. So within 30 to 60 minutes, you're supposed to get your result. The discoloration will occur. And then for those who are deficient, the discoloration time is between 2 to 24 hours. Okay, so that's about that. So let me take this to the incubator, and then so this is our incubator. It's actually a water bath. You can alternatively use an air bath, it's also fine. So I'll put it in and I'll show you what we have in there. Okay. So I have 2 here, 1 here, and then I have another one here, which still looks blue after 2 hours. But look at this one. So it looks brownish. Yeah. So it means that this person is normal and this person is likely to be defective. So we'll leave it for, let's say, 24 hours, and then we would observe the results. Okay, so I left out one important thing on this one, so let's get back. So after you actually have this, you're supposed to transfer 1 ml of the reagent 4 or the inert oil onto it. So this is the inert oil. You are supposed to transfer 1 ml of it onto it, and then you go and do the incubation. Please take note, I missed that point. Okay, so let me do that, and then I can incubate. Okay, but I've already demonstrated how to read the results, so I wouldn't go back to that. Okay, so I have it here. I open it, and then we do 1 ml. So you can see the oil on top. You can see that. So the inert oil will be on top, and then you cover, and then you can incubate. Okay. So, but I've already showed you how to read the results. If the person is normal, you will see the brown color, and if the person is defective after 24 hours, the color will still be blue. Okay, so that's about how to do this test. Let me know if you have any questions. and I'll answer them. Okay.